time for everything you need to know about algebra, part 2. So there are a couple properties that we're going to use as we go through algebra. Let's talk about them in addition first. We're going to talk about the commutative property and the associative property. Commutative is all about the order. 2 plus 3 is the same as 3 plus 2. We know that just like intuitively without even thinking about it. But don't forget that it's the same even if you have a really long list of things. 2 plus 7 plus 10 is the same as 2 plus 10 plus 7. Even if this list went even longer, the order doesn't matter when I'm only adding. Obviously, we have to use order of operations if there's more things than adding, but if we're just adding, order doesn't matter. Flip them all around, all you like. The associative property is all about parentheses. So if I think about that same problem, 2 plus 7 plus 10, and I had parentheses in it, so I add 2 plus 7 first, and then add the 10, I will get the same answer as if I put the parentheses at the end and did 7 plus 10 first and added my 2 in later. Associative is telling me that if everything is addition, it doesn't matter where the parentheses are. Now those same properties hold true in multiplication. 2 times 3 is the same as 3 times 2. And if we were to put parentheses into a problem like 2 times 5 times 8, I know that 2 times 5, which is 10, times 8 is going to be the same as if I did the 5 times 8 first to get 40 and then times it by 2. On both sides, I'm getting an answer of 80. It doesn't matter where I put the parentheses in if everything is multiplication. Now, just as important, but in my mind much more interesting, is the distributive property. The distributive property tells me that when I am multiplying by a bunch of stuff inside parentheses, I have to multiply by everything inside those parentheses. For me, the way I remember is I imagine a beautiful rainbow going from the number that's being multiplied to everything in the parentheses. And this is true no matter how many things there are inside your parentheses. Let's say you had a ton of things. Even when there are tons and tons of things inside the parentheses, you have to have a rainbow. Oh, these are not very pretty rainbows. To every single thing, because the 4 or whatever number is on the outside is being multiplied by everything on the inside. You can't multiply it by just some of it. You have to multiply it by all of it. The distributive property is what is helping you when you are breaking down a problem in your head. So if you were doing 6 times 13 and you don't know it off the top of your head, you might use the distributive property to say, oh, but I know what 6 times 10 is, and I know what 6 times 3 is, so I do actually know what 6 times 13 is. So how do we use these 3 properties to know when expressions are equivalent to each other? If I have an expression that's all multiplication, then I know that the order doesn't matter. I could change the order and still have an equivalent expression. I could move the parentheses and still have an equivalent expression. I could simplify and still have an equivalent expression. When there's both multiplication and addition and subtraction, I can't just rearrange it, but I know I could still change the order it's being multiplied in, or I could change the order that the addition is happening in, or I could use the distributive property to multiply the 3a by everything inside the parentheses. Now that I have everything in addition, I could reorder it again if I wanted. There are so many ways to write an equivalent expression to one you already have. We could even be little pains in the butts and rewrite this as 3a times b plus 2 plus 5. that is still an equivalent expression because 2 plus 5 is going to be the same as 7. There's one last way to write an equivalent expression, and it's honestly so simple that we don't usually even talk about it or count it as an extra one, but it does always work, and we use a version of it to simplify other things like fractions. That is the identity property. The identity property for addition is that you can add 0 and it's still going to be an equivalent expression. The identity property for multiplication is that you can times by 1 and it's still going to be an equivalent expression. For this one here, I could change this to 2 times a times 1 plus 5. Still going to be equivalent. I could do it as 2 times a plus 5 plus 0. Still going to be equivalent. People might think that you're being pedantic, but they certainly are equivalent. So, to sum up, we have the commutative property for addition and multiplication. It means the order doesn't matter. We have the associative property in both addition and multiplication. That's saying you can move the parentheses to a different spot and it's not going to change the overall value. And we have the identity properties. In addition, you can always add 0. It won't change anything. In multiplication, you can always multiply by 1 and it won't change anything. And don't forget the best and greatest and most helpful, the distributive property tells us that when we have something on the outside of parentheses, we have to remember to multiply it by everything inside those parentheses. So this 3x gets multiplied by the 2y and by the 4. We could write it like this, or we could simplify it to this. Another way that we can represent the distributive property is thinking about it as an area, a length, times the width, and we just draw ourselves a little rectangle. Length times the width, and we have 3x times the 2y and 3x times the 4, and those together give us our total area. It's solving it the exact same way, it's just a visual model instead of the rainbows. Okay, you know everything you need to know about algebraic properties. Great job!